In this lesson, we will explore Ohm's law, which is the most important principle in electrical engineering, and we will use it through this entire course. In the previous lesson, we learned that the RC circuit behaves as follows. When we start the simulation, the energy from the voltage source starts flowing through the resistor and accumulates in the capacitor. If the resistor value is small, the energy flows faster. If it is larger, the resistor opposes to the flow of energy and the capacitor charges slower. In order to understand why this happens, we need to understand the concept of voltage and current. For that, we will explore the following circuit, which consists of two voltage sources and one resistor. Each voltage source is connected to one terminal of the resistor. In this case, each source is trying to push energy into the resistor. And which one will win? The one that is stronger. On the left we have a voltage source of 2 volts. On the right is 1 volt. The resistor sees the difference of these two voltages, and the difference is the effective voltage in the resistor. That voltage makes the energy flow. In this case, it will flow from left to right, and this flow of energy is what is called current. Let's make a few experiments to have a better idea on what's happening in this circuit. Here we can see in the plot the voltage difference that the resistor experiences. The voltage values of the sources is defined here. The source in the left provides 2 volts and the one in the right 1 volt. In the bottom plot, we can see the amount of current that is flowing through the resistor, which is 1 milliampere or 0.001 amperes. Let's see how the results are affected when we change the values. If we increase the voltage of source 1, we can see that the difference, which is what the resistor sees, becomes larger. That also increases the amount of current that is flowing through the resistor. If the values of both sources are the same, we can see that the voltage in the resistor is 0 and there is no current flowing. If we make the voltage of the second source larger, we can observe that the voltage in the resistor is negative, and also the current through the resistor is negative. This means that the current is flowing in the opposite direction. In this simulation, the voltages and currents are measured from the blue terminal to the white terminal. And a negative current means that the current flows from the white to the blue terminal. One analogy that we can use to understand this behavior is the following. Imagine a slanted table like the one in the drawing. If we place a ball on top of the table, the ball will rotate towards the end of the table. The height of the table represents the voltage, and the ball experiences a push that depends on the difference of heights of the two extremes. In a resistor, the larger the difference of voltage across its terminals, the higher will be the push of this energy to flow. This effect is described by the following equation, which is in fact Ohm's law. The symbol I represents the current, which is given in amperes. R is the resistance of the conductor, and V is the voltage. We can see in this equation that an increase of the voltage will result in a larger current, but for the resistance R, it is the opposite. The larger the value, the lower the current. You need to remember this simple equation because we will use it in almost every lesson of this course. Now that we know the equation for Ohm's law, we can better understand the numeric values that we're seeing in the simulation. In this case, we have a voltage of 1 volt, and the second source is set to 0 volts. Then the difference, it is 1 volt. And in order to obtain the current value, we need to divide 1 volt over 1000, which is the resistor value, and that gives us the 1 milliamp. By increasing the resistor, we can see that the amount of current is being reduced. It's 0.3 milliamps. And the opposite happens as we make the resistor smaller. As a summary for this lesson, we learned that the flow of energy through a conductor is called current, and its unit is amperes. The relation between current and voltage and resistance is described by Ohm's law. We determined with this equation, and also by running simulations, that if the voltage is large, the current will be higher. If the resistance is large, it will oppose to the flow of energy, and there will be less current. In the following lesson, we will shift our attention to the capacitor in order to better understand its behavior.